So this is practice set 5.1, sum number 2. Determine whether the points are collinear. And sub question number 2. We have been given 3 points L, M and N. Coordinates of those points have been given and the question says to find whether the points are collinear. Ab bacha, in order to find points as collinear, we should find their distance first. So in order to find their distance, let's begin with the solution and let's take 2 points, point L and point M. Let's take coordinates for point L as x1, y1 and for point M as x2, y2. Therefore, x1 becomes minus 2, y1 becomes 3, x2 becomes 1, y2 becomes minus 3. Great. Therefore, by distance formula, distance of L, M is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. In the next step, let's substitute the values. Is equal to square root of x2 is 1 minus x1 is minus 2. So this is 1 minus into minus 2 the whole square. So I can write this as 1 plus 2 the whole square. Plus y2 is minus 3 minus y1 is 3. So this is minus 3 the whole square. Next step, equal to square root of 1 plus 2 is 3. So this is 3 square plus minus 3 into minus 3 gives me minus 6. So this is minus 6 square. Next step, equal to square root of 3 square is 9 plus minus 6 square is minus into minus plus 6 into 6 36. So this is plus 36 and this plus into plus becomes plus. Equal to square root of 9 plus 36 is 45. So square root of 45. Is it a perfect square? No, it is not. So we need to factorize this. Equal to square root of 45 can be written as 9 into 5. Square root of 9 into square root of 5. Okay. So square root of 9 is what? It's 3. So this is 3 root 5 units because root 5 cannot be factorized ahead. So therefore distance of L, M is equal to 3 root 5 units. Mark it as equation number 1. Next, let's take point M and N and find the distance between them. So let's take coordinates for point M as x1, y1 and for point N as x2, y2. Therefore x1 becomes 1, y1 becomes minus 3, x2 becomes 5, y2 becomes 4. Therefore, by distance formula, d of m, n is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, the formula. Next step, let's substitute the values. Equal to square root of x2 is how much? 5 minus x1 is how much? 1. So this is 5 minus 1 the whole square plus y2 is how much? 4 minus y1 is how much? Minus 3. So this is 4 minus into minus 3 which can also be written as 4 plus 3. So this is 4 plus 3 the whole square. Next step, equal to square root of 5 minus 1 is 4. So 4 square plus 4 plus 3 is 7. So this is 7 square. So this step is square root of 4 square plus 7 square. Next step, equal to square root of 4 square is how much? 16 plus 7 square is how much? 49. So this is square root of 16 plus 49. Next step, therefore, distance of Mn is equal to square root of 65. Ab, can 65 be factorized? Oh, first let me ask you, is 65 a perfect square? No, it is not. Can it be factorized? Even if we factorize it, then too we won't get the perfect square anyway. So, however, let's continue and let's write square root of 65 as equation number 2. Next, let's take points that is L and N and find the distance between them. So let's take coordinates for point L as x1, y1 and coordinates for point N as x2, y2. So x1 becomes minus 2, y1 becomes 3, x2 becomes 5, y2 becomes 4. Let's apply the distance formula. Therefore, by distance formula, distance of L, N is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square equal to square root of x2 is how much? 5 minus x1 is how much? Minus 2. So this is 5 minus into minus 2. So we can write it as 5 plus 2. 5 plus 2 the whole square. Plus y2 is 4 minus y1 is 3. So this is 4 minus 3 the whole square. Next step, equal to square root of 5 plus 2 the whole square gives me 7 square. Plus 4 minus 3 the whole square gives me 1 square. So this is square root of 7 square plus 1 square. Next step, equal to square root of 7 square is 49 plus 1 square is 1. Next step, square root of 49 plus 1 is 50. So this is root of 50. Square root of 50, is it a perfect square? No. But can it be factorized? Yes. So let's break it. Equal to square root of 25 into 2. Now we all know square root of 25 is 5. Because 5 5 is 25. So 5 into root 2. Because root 2 cannot be factorized ahead. And this is 5 root 2 units. Therefore distance of L comma N is 5 root 2 units. Mark it as equation number 3. So let's have a look at all the 3 equations now. Equation number 1, 2 and 3. Which is the biggest one? It is root of 65. Why? Because other 2 equations are, one is 3 root 5 and another is 5 root 2. And equation number 2 is root of 65. So it is bigger than other 2 equations. So let's add equation number 1 and equation number 3. Therefore, distance of L comma M plus distance of L comma N is equal to 3 root 5 plus 5 root 2. Mark it as equation number 4. Now let's compare equation number 4 and equation number 2. Are they equal? No, they aren't. So we can say that distance of M comma N is not equal to distance of L comma M plus distance of L comma N. Therefore, we can say that points L minus 2 comma 3, M 1 comma minus 3 and N 5 comma 4 are not collinear. I hope you have understood this sum. Thank you.